In this module, we will cover the factory method pattern. The idea is that this pattern lets a class defer instantiation to one or more subclasses. I'm Kevin and I'll guide you through it. We'll start by describing the pattern. As a real-life example, we will use a shopping cart checkout context. We'll create a factory with a factory method to provide us with the correct discount service implementations, because discounts might be different per country, per code, and so on. We will use that example to learn about the pattern structure and we will implement it. After that, we will continue with learning about use cases for this pattern and pattern consequences. We will end the module by looking into related patterns. Let's dive in. The factory method pattern is a creational pattern from the well-known Gang of Four design patterns. Creational patterns deal with object creation, and using a factory method is a very common way of doing that. It's also known as a virtual constructor. These days we don't really talk about the factory method pattern a lot anymore. We simply talk about the factory pattern. But if we want to be correct, the factory pattern can refer to either the factory method pattern or the abstract factory pattern, which we'll cover in the next module. Once we've done that, we will compare both, also in the next module. For now, let's focus on the factory method pattern. Its intent is to define an interface for creating an object, but to let subclasses decide which class to instantiate. In other words, factory method lets a class defer instantiation to subclasses. Let's clarify this with an example. Imagine that you're creating part of a shopping cart system. At a certain moment, a discount can be applied. One of the services that can provide a discount is a service that provides a discount depending on the country the user is in. Another one provides a discount depending on a discount code. So, both services are not constructed in the same way, nor is the logic to calculate the actual discount the same. Yet they do have something in common, the discount percentage that needs to be exposed. We could write some code that newes these classes up and gets the discount percentage. That's what you see on screen. Yet this creates tight coupling between the client class, which is instantiating them, and the different discount service implementations. The factory method pattern helps avoid that. We do that by adding a base class or interface named discount service. It's this class that any part of the application that needs to know the discount can interact with. The concrete implementation isn't important for the client. Now, the client, which is part of the shopping cart system that needs to know the discount, does not need to know which actual subclass it needs to instantiate. It doesn't care whether it's the code discount or country discount service. All it needs to know is when it needs such an instance. But how do we instantiate it then? For that, we create a base discount factory with one abstract method, create discount service. This is called the factory method. Concrete implementations of this factory are then a code discount factory and a country discount factory. The client works on the discount factory base class, so it uses whichever implementation is provided to get a hold of the concrete implementation of the discount service via the concrete implementation of the discount factory with the concrete implementation for the discount factory method. Via the factory method, we encapsulated the logic to create the actual subclass, so the client doesn't need to know about that anymore. And because we're working on an interface instead of a concrete implementation, we prevent tight coupling. Let's map this to the pattern structure. When we map this to the pattern structure, we start with the product. That could be an abstract base class or interface for the thing that needs to be created. It thus defines the interface of objects that the factory method creates. In our case, that's the discount service class. Then we have concrete products, the implementations of that product interface. If we map that to our example, that's the code discount service and country discount service. The creator then declares the factory method. This factory method must return an object of type product. In our case, that's the discount factory, with the abstract create discount service method on it. We can map that to factory method. The creator itself may also call the factory method to create a product object. And lastly, we have the concrete creator. These are implementations of creator which override the factory method to return an instance of a concrete product. Mapped to our example, these are the code discount factory and country discount factory. And with that, we've got our pattern structure. Let's implement our example in a demo. Time to implement the factory method pattern. Let's start with our product, the discount service. This is an abstract class, as we want it to serve as an interface for a concrete implementation. On it, we can add properties or methods like the discount percentage that can be used by clients. This, too, is marked with the abstract keyword, as we want the concrete products to implement the logic behind this. Note that, as with most pattern implementations that require an abstract base class, you can use an interface as an alternative. As an example, I will use an interface in the next module when we'll look into the abstract factory pattern, a pattern closely related to this one. We also override the toString method, so it returns the actual type name. That'll make it easier to see what's going on when we test this. Then let's implement this. We add a country discount service, which implements our discount service abstract class. This is a concrete product. Depending on the passed-in country identifier, a different percentage must be returned. So we store the identifier in a read-only field. We do not want it changed after the object has been constructed. Then we override the discount percentage, as it's up to the concrete implementation to decide on this. Let's say that for this demo, when you're from Belgium, you get a better discount. Purely coincidental, of course, the fact that I happen to live in Belgium has got nothing to do with this at all. Our next implementation, then, is a code discount service. We start in a likewise manner. The discount service is implemented and we override the discount percentage property. Let's say that each code results in the same discount percentage, but a code can only be used once. In real life, this is where you could add that check. We're not going to implement that here, because what is important for us is that we ended up with two different concrete products. Up next, the factories. As we learned, we start with an abstract discount factory class with one abstract method, create discount service, which returns a discount service, the base class for our concrete discount services. And then we need to implement the concrete implementations. Country discount factory news up a country discount service for which it needs the country identifier. So it's this factory that's responsible for creating a country discount service. And in a likewise manner, our code discount factory is responsible for creating and managing the lifetime of the code discount service, passing through a code it gets from the code discount factory constructor. And with that, we've got all the moving parts of our pattern in place. We can test this. Let's switch to the program.cs file. And first, let's create our two factories. For that, we need to import the factory method namespace. We store these in a list, which makes it easy to run through them to see what's going on. It's through these factories that the actual services can be created. So that's what we do next. We run through our list of factories, and on each factory, we call create discount service. That means that this client is doing the call on the discount factory base class. And then we write out the percentage and where it's coming from. Like that, we can see what was actually created. Important to remember here is that the client does not know about any concrete implementations. The factories it works with are abstract, and so are the discount services. Let's give this a try. And there we go, 2 concrete products were created by our 2 concrete factories without the client having to know about the concrete implementations. That's it for the demo. Let's cover the use cases for this pattern next. Good use cases for this pattern are when a class can't anticipate the class of objects it must create. In other words, when you don't know in advance which types of objects your code should work with. When that's the case, the concrete creators can take on this responsibility. Another good use case is when a class wants its subclasses to specify the objects it creates. This enables the scenario in which standard components or classes can be extended via subclasses. Here, too, this means the concrete creator takes on the responsibility for creating the objects. Up next, when classes delegate responsibility for creation to one of several helper subclasses, and you want to localize the knowledge of which helper subclass is the delegate. Localization of that knowledge is now at level of whichever part of your application is responsible for providing the concrete implementation of the creator that's needed. And you can also use it as a way to enable reusing of existing objects. The logic inside of the factory method can take care of either creating an object or reusing an existing one as it sees fit. If you're newing up instances yourself, you'll either have to write code like that wherever you new it up, or put it in a reusable method. And that reusable method, that's the factory method. Let's cover the consequences next. A main consequence of this pattern is that factory methods eliminate the need to bind application-specific classes to your code, to the client, for example. And that's because the code only deals with the interface, the product, and not with the concrete implementation. That means it can work with any concrete product implementation. In other words, you're avoiding tight coupling. It's this that enables adding new types of products without breaking client code. And that's the open-closed principle at work. The single responsibility principle is also adhered to. Creating the products is moved to one specific place in your code, the creator. That's only responsible for that. A potential disadvantage is that clients might need to create subclasses of the creator class just to create a particular concrete product object. If only one subclass, so one concrete creator, is expected to be needed, you would have just added unnecessary complexity. Let's have a look at the related patterns next. Closely related to this pattern is the abstract factory pattern. It's often implemented with factory methods, as we will see very soon in the next module. There's also a relation to another creational pattern, the prototype pattern. Prototypes don't require subclassing creators. They are not based on inheritance, which is a plus when you favor composition over inheritance, which, as we learned, the Gang of 4 do. However, they often require an initialize operation on the product class, which the factory method doesn't. So, factory method is based on inheritance, but it doesn't require the initialization step. Lastly, there's also a relation to a behavioral pattern. Factory methods are usually called within template methods. On to the module summary. In this module, we learned about the factory method pattern. Its intent is to define an interface for creating an object, but to let subclasses decide which class to instantiate. Factory method lets a class defer instantiation to its subclasses. We implemented this with a discount service example. Important here is that this pattern eliminates the need to bind application-specific classes to your code, to your client, for example. You will notice throughout this course that a lot of patterns will also help with this. As far as implementation goes, in C#, the product can be implemented as an interface or abstract class. Same goes for the creator itself. On its concrete implementation, a method must be implemented to create a concrete product. That's the factory method. Up next is a closely